Is there anyone? Which topics we had covered out of 6 subtopics? We had started our biomaterial and bioactive compounds, if you remember. After that, we had started with first was antibiotics. After that, second was, is there anyone? Second was enzymes, if you remember. After that, we had started with our next subtopic, that is nothing but third was alkaloids. Okay, so we completed with alkaloids. Now we will continue with this topic. There are certain bioactive compounds and biomaterial, including biominerals. Now, what biominerals are? So these are the inorganic compounds that are produced by some marine living organism in association with the organic molecule. When inorganic compounds are formed or produced in association with organic molecule, that will be considered as biomineral. And marine organisms like shells, skeletons, spicules, these are all responsible for the process of biomineralization. That means in association with organic molecule, they will form or produce some inorganic compounds. So again, I'm repeating some topics like we had started our topic. First bioactive compound we studied was antibiotics. After that, second was enzyme, and third was alkaloid. Now, fourth subtopic is nothing but biominerals. Now, biominerals are inorganic compounds that are produced by living marine organism. Often, they will synthesize this inorganic compound in association with the organic molecule. And this process is nothing but biomineralization, where there are certain shells, skeletons, spicules. These are all marine organisms. These will form biomineral. Now, which are the types of marine biominerals? So, marine organism, they produce variety of biominerals like calcium carbonate, silica, calcium phosphate, magnetite, strontium sulfate, and barite. If we start with our biomineral calcium carbonate, main component in this biomineral is the aragonite and calcite, and corals, mollusks, and foraminifera. These are the marine organisms that will produce calcium carbonate biomineral. After that, diatoms, radiolarians, sponges, they will produce silica biomineral, and in silica, amorphous hydrated silica is the main component. Then marine vertebrates are there like fishes, bone, teeth. They will be producing or they will be responsible for the production of biomineral, that is nothing but calcium phosphate, and the main component will be hydroxyapatite. After that, magnetotactic bacteria are marine organisms that are responsible to form the biomineral, that is magnetite. And the main component of magnetite is magnetic iron oxide. There are certain plankton species like plants, algae. They will synthesize strontium sulfate barite biomineral, and the main component of this is nothing but strontium sulfate and barium sulfate. So these are all the biomineral, their main component, and organism which is responsible for the formation of biomineral. After that, marine organisms and biomineralization. Mollusk, I have shared diagram as well. So they will secrete calcium carbonate to form their shell, and shell are the protective part. And these are also considered as nacre, mother of pearl. They use protein, that is conchiolin, to guide the mineral deposition. So for the mineral deposition, there will be protein responsible, that is called as conchiolin. After that, corals are also responsible for the formation of biomaterial, that is CaCO3. And biomineralization is also a responsible part for the carbon cycling. At the same time, it is also responsible to maintain the pH. Third will be diatoms and radiolarians. Now, diatoms and radiolarians, these are all the examples. They usually form silica shells and skeletons. Frustals are the example. And these are mainly responsible for the silicon cycling. So first organism was mollusk, then coral, then diatoms and radiolarians. After that, marine biominerals are being explored to biomedical and technological applications. How they are applicable in biomedical field, how they are applicable in, these are all the properties in biotechnological field. So if we talk about biomedical application, bone graft and implantation from these coral derived calcium phosphate is the most efficient biomineral. The durability, at the same time, when you talk about if you remember, I have shared one example, that is root canal, tooth repair. So in that also these biominerals have been used, and form will be calcium phosphate. At the same time, the silica, the atom silica, that is responsible to the process of drug delivery. In the wound healing system, these hydroxyapatite, chitosan composites, these biominerals are very essential. So, if you talk about biominerals, first was biominerals are inorganic compound that are produced by marine living organism with the association of organic molecule. In marine environment, biomineralization is very significant. They are formed by shells, skeletons. They are found in shells, skeleton, spicules, and other tough structure. Wherever there will be tough structure, just consider that these are the biomineral. After that, there are certain biominerals, their main compound and marine producers have been discussed, like calcium carbonate, silica, calcium phosphate, magnetite, strontium sulfate, and barite. These are all the biomineral. Then we discuss about some marine organism, how and in what composition they will release biomineral. After that, if we talk about marine biomineral, they are very useful as a biomaterial and they are very important in the biomedical field, like bone graft. After that, implantation, bone implantation. In that also, you can use calcium phosphate biomineral that is synthesized by marine organism. After that, drug delivery system. For the drug delivery system, you can use diatom silica for controlled release. That means targeted therapy, for the targeted therapy. In the enamel, tooth layer, tooth repair, you can use calcium phosphate. Then wound healing with marine derived hydroxyapatite and chitosan composites are being used. Then, how biominerals are very important in the field of biomaterial, because they are responsible for biomineralization. Then they are having good biocompatibility. Their mechanical properties are very essential, and it is very positive when we talk about biomedical field. They show controlled mineralization, and they are inspiration for new biomaterial. So, first is biomineralization. When living organism use biomineralization to produce tough tissues like bone is a tissue, teeth is a tissue, shells are tissues. So when these tough hard tissues are formed, that process is biomineralization. And in bone regeneration, bone repair, after that, in the root canal for filling of the cavities, you definitely can prefer these biominerals. After that, as they are very biocompatible, that means they are well tolerated by living tissues. Normally, what happens if you implant something in our body give negative signals to that. It will start rejecting that foreign particle. But when we talk about these biominerals that are synthesized by a marine organism, these are very good biocompatible things, and our cells can well tolerate this biomaterial. This makes them attractive for use in the biomaterial that come into contact with the body, like dental implant, bone scaffold. You can use these biomineral for the framing purpose in scaffold, for the implantation in dental or oral things. At the same time, their biocompatibility is very essential when we talk about insertion, because that is the foreign particle that we are inserting in our body, and our body can reject that. So this biomineral is very essential for the easy accessibility. After that, mechanical properties. Biominerals often exhibit a superior mechanical property, like they are very tough, they are having good strength as compared to synthetic material, and that's the reason they are more valuable for developing the biomaterial when you talk about the enhanced mechanical performance. After that, controlled mineralization. When we study mineralization process, we can control the formation, we can control the structure of mineral, and that's the reason they are highly specific in their property. And last is inspiration for new material. So when we talk about new material, we can combine these biominerals in a unique way so that you can get their more beneficial property. And nowadays, researchers have developed synthetic material that will mimic the natural material. Like if you talk about pearl, you all know that pearl, the range varies from 50 rupees to 5 lakhs. Can you imagine how this comes? So the pearl that is cheaper in quality, for sure it is the synthetic material, and the mimicry is done. Of course, that shopkeeper will tell you that it is the original one. These are the basic tests that you can perform with this pearl, but that is not original one. Original one, synthetic one is prepared by mimicking the properties of original one. So this is also good business. Economically it is very important, because everyone cannot afford that 5 lakhs pearl. So at that time you can go for this. So these are all the properties of biominerals. Is there any doubt in the biomineral? You can ask. Any doubt? Should I go to the next topic? Okay. Avnita, is there any doubt?
No, ma'am. Thank you.
Okay. Okay. We will proceed to our next subtopic, that is, who can tell us? 6 biomaterials or bioactive compounds were there. That is, next topic, biocomposites. So, when materials are formed with 2 or more different components. Now, if I am forming a material with the combination of 5 components, just imagine in that 5 component, one component minimum, at least I'm saying one component should be biological material. Four can be synthetic, one must be biological material. You can keep two biological, three synthetic, three biological, two synthetic, four biological, one synthetic. So, what biocomposites are? These are the materials that are composed of two or more different components where at least one component is a biological material. When we talk about this material, these materials combine the property of non-biological with biological component to achieve a specific functional property. So, if we talk about biological, non-biological component combination, their specificity plays an significant role. Biocomposite offer a versatile platform for the development of biomaterial. So biomaterial, for the biomaterial development, you can use these biocompounds or biocomposites, and that are very specific, very applicable in the medicine and biotechnology. The combination of biological, non-biological component is very efficient, and their functionality, their performance is enhanced. That is the reason we're combining these two components, so that there should be a equal balance. So what biocomposites are? Biocomposites are nothing but the material that are formed of two or more different components, where there must be one component with biological material, and this material will show both the properties, biological and non-biological one. Biocomposite, they are very important for the development of biomaterial, and their application in medicine and biotechnology is very essential. The combination of biological, non-biological component allows for the design of material. And this combination, why we are doing combination? To enhance the functionality and performance. So this is the introductory part. Now, what about marine sources? So marine organism, they provide a good, huge source of bio-based polymer and bioactive fillers. Like, there are certain example, polymeric matrix component. This is the base material. Chitosan can be used, alginate can be. Please switch, turn off your mic. Collagen and gelatin, flucoidin. These can be used while making the biocomposite. Now, chitosan is mainly, these are all the biocomposite. You can mix two, you can mix three, one, two, or three. You can make any combination as per your function. Like in the biofilm, we use chitosan. In the biofilm, we use gelatin. Now our research is also going on chitosan and gelatin various combination. So it's up to you what you have to use and in what concentration and what is the function.